Alright, so I'm going to start a video on how to do the example problem that was on my big campus. I'll read it to you and we'll start solving it. So the question is, little Mr. V was swinging on a swing in the first grade and jumped off, causing him to have the wind knocked out of him, which at the time felt like imminent death. He left the swing at an angle of 30 degrees above the horizontal, and he was 1.3 meters above the ground when he jumped. So we have some kind of angle here. It's 30 degrees, and basically this was, we'll say, 1.3 meters above the ground. A says if his initial velocity was 8 meters, so that's here, per second, find out how far he flew before landing and receiving a face full of wood chips. So basically they want to know, if this is the trajectory, how far, what's the delta x? So first thing we have to do is break this up into components. 8 meters per second, 30 degrees. We need the v initial in the y direction and the v initial in the x direction. If we use SOHCAHTOA, we know that to get the x we have to use CA because it's adjacent and this is hypotenuse, so we have this side and we're looking for this side, we have the angle. So it's cosine of theta is equal to v initial x over v initial. We're going to go ahead and plug everything in and rearrange, and we'll get v initial x is equal to 8 times cosine 30. You'll find that v initial y is just 8 times sine 30. So I'm going to go ahead and plug that into my calculator. So I have 8 cosine of 30. Make sure you're in degree mode. And 8 times sine of 30. So my x is 6.9 meters per second, and my y is 4 meters per second. Now your next step is to check, is this positive or negative? If you look here, you remember, positive is to the right, positive up, so they're both positive. I'll write a little plus sign so you remember. So now that's all the new stuff. Now we just go back to doing our projectile motion problems. You have to set up the x and the y chart, so you have delta x, v initial, v final, acceleration, and time. Plug in what you already know. V initial is what we just found out, so the x direction is 6.9 meters per second. The y direction is 4, both positive. We know that the v final is going to be the same because there's no acceleration there. And v final we're not sure about at this point. That's actually the next part of the question. Delta y is going to be negative 1.3 meters because I'm falling from here down. So it's going to be 1.3 is the initial, 0 is the final, so 0 minus 1.3 gives you a negative 1.3. So now what we have to do is find time. Well, actually, first we look here. We want to find delta x, but we can't get it because the 0 is going to mess us up. So what we can do is find time here, but you'll also notice that you'll get a quadratic unless you solve for the v final first. So just quickly we'll solve for that. Oops. Just using this equation because it doesn't have time in it. V final is what we're looking for. V initial is 4 squared plus 2, negative 9.8. Make sure you got that negative in there, and negative here. And finally, we just go ahead and solve. So 2 times negative 9.8 times negative 1.3 gives you a positive 25.48. Add that to 16. Now, one thing a lot of people make the mistake of here is saying it's just 41.48. That's squared. Remember, we have to square root that. So when we square root that, we get 6.44 meters per second. That's our v final. And what we're going to do with that now is plug it in here. So we have 6.44. Now, is that positive or negative? Well, think about this trajectory here. At the end, it's going to be going something like that. If it's going down in the y direction, that's going to be negative. So we know that that's going to be negative there. Finally, we can get time just by doing this equation here. V final is equal to V initial plus AT. V final is negative 6.44. V initial is positive 4. Negative 9.8 times T. Just solve that quickly. First, you subtract 4 on both sides, so you get a negative 10.44, and then divide that by negative 9.8. Remember, you should get a positive time, 1.07 seconds. Alright, and now finally, you want to find delta x. To do that, you can just plug it into this equation, but you know that this is just going to be 0 because that's going to be 0. So then you just get delta x is equal to 6.9 times 1.07, and that answer is something around 7.35 meters. And that's the answer for part A. So that's how far I fly before I hit the ground. The next one is going to ask you how fast was I going at the end. You need to take the two final velocities that you had from here. Here's my chart. My final velocities was plus 6.9, and this is negative 6.44 because it was going down. So I'm just going to rewrite them on here. Plus 6.9 and negative 6.44. That's about the same. They're close in size. So that means 6 point extra, positive 6.9, 6 and negative 6.44. Just a little math intuition here. Because they're close in the same size, I'm expecting an angle around 45, somewhere in the 40s. So now we go ahead and do Pythagorean theorem to get this side here, which will be our V final total. So it's just going to be V final squared is equal to 6.9 squared plus negative 6.44 squared. You know that this is going to turn into positive when you square it, so don't worry about that negative sign. So you end up getting V final squared is equal to 89 meters per second. And then finally, when you square root that, you get 9.44 meters per second. And you don't put positive or negative, you just leave it. It's the absolute value. So this is how fast I was going as I hit the chips there. The last thing you need is the direction, because a velocity needs a direction. The way we get that is we use TOA. So that's tan theta is equal to opposite over adjacent. In this case, opposite is negative 6.44. Adjacent is 6.9. And we need to get theta by itself. In order to do that, we have to tan inverse both sides. And then if you can imagine, sorry, I shouldn't have squeezed it in like this. These are going to cancel out, and you're left with theta is equal to tan inverse of negative 6.44 divided by 6.9. Make sure you're in degree mode. I have to press the green button to get tan inverse. It's negative 6.44 divided by 6.9 gives me a negative 43 degrees. Like I said, that's going to make sense. I figured I would get it close to 45. And we know it's negative because it's below the x-axis. Another way you can write this is you can say 43 degrees below x-axis, or 43 degrees south of east, whichever you prefer. So that's your angle. This is your final speed. Hope that helped.